Alright, here we go. So what we're in today, we're in section 4.7. This is stuff we started Friday, but we didn't get too far into it. But section 4.7, the title of it is called Scientific Notation. Scientific Notation. And it's a way of writing really extremely big numbers into smaller numbers. Okay? So it's pretty straightforward in the way it works. So the goal today is to look at the two types of numbers. Now what I mean by two types, I'm actually talking about classifications of them. Okay, classifications. What we're going to be comparing today is whole numbers or natural numbers versus a decimal. So these are natural numbers.
Versus.
And anything we can write as a decimal, so these would be rationals. Rational numbers. Now, technically, natural numbers are rationals. They are, because you can always make a number a fraction. But these are the two types we're going to be dealing with today, and we're going to be trying to convert. The goal is to put it into what they call, quote-unquote, proper scientific notation. And we're going to discuss that today. So this is going to be one of our major words I want to talk about today. This is a way of, if you get a weird answer in your calculator, especially when we do the MAPS testing, or we do ITBS testing, or anything like that, and you get a weird answer in your calculator, you actually know what it's telling you. That's what we're going to look at today. Question?
I do get a question about those. When do we do those?
MAPS testing, for us, I believe, is like, I think the last time I read was...
What's in the last week of this month?
What was it? Yeah, like the 21st through the 28th is MAPS testing.
27.
Yeah, so what is that? Is that next week? Next week?
Week after.
Week after. We start MAPS testing, and then the ITBS testing is like April or something like that.
April 3rd.
Yeah, something like that. So they're coming up soon, and the reason I want to do this is in case, because you guys have been talking about adding, subtracting, multiplying, dividing decimals. You should be hopefully better at that. We added, divided, multiplied fractions. We did that in the last chapter. And hopefully you feel a little more comfortable with that stuff. Well, this is something, if you did some form of decimal on your calculator and it gave you an answer that couldn't fit, your calculator would actually choose to do this. And I need to make sure that you know what the answer is. Okay? So that's what we're going to be looking at. And that's why this seems like we're out of kind of nowhere, that we're just only going back into weird decimals. But we need it. We do need it. So let's talk about the first one. So we're going to start with natural numbers. So a natural number, if you don't remember, is any number. So natural numbers are any number from 1 and up. But they're not fractions, they're not decimals, they're nice clean numbers. They can be any number up through positive infinity in that direction, right? So I think one of the examples I think I gave you yesterday was something like 24,500,000 or something like that, right? This is one of our numbers. Okay, that is a natural number. It's huge, right? Like, Jake, just put it on the desk. Yeah, perfect. Thank you. All right, so 24,500. That number is huge, right? It's a big number. Now, I know in most calculators that number can fit. An 8-digit calculator can fit that because that is exactly 8 digits. But if we went past that, some calculators wouldn't be able to do it. Like, for instance, my little Texas Instrument thing here that I bought from Dollar General for like $2. It can do pretty much everything I need it to, except for I can't go past that. I can't go past, let's say 99 million, because it can only go out to 8 digits. And I can't go to 9, so I couldn't go 100 million. And I couldn't add numbers like that. Even though I could get 100 millions in math, I can't get it on this calculator. It won't give me the right numbers. So it will eventually, like especially my scientific calculators, it'll shorten this number up. It'll show me the same number, but make it smaller. Okay? Alright, so here's the idea. Here's how you do it. The decimal is in the back. It's way back here. What I'd like you to do is move the decimal all the way until it's behind the first number on the left. So what's the farthest number on the left? Farthest number on the left?
2.
2. We're going to put the decimal behind the 2. And you're going to write down some of the other significant numbers that are after it.
So
if there's any zeros, we chop them off.
So this is like where we had to move the decimal
that way instead, but now we slip.
Moving it back.
Okay.
So we're moving the decimal all the way back. Now, how many spots did you move your decimal? How many spots did you move your decimal? Count.
1, 2, 3, 4,
We're going all the way to here.
5 or 6.
Oh, keep going. Keep counting. What is up to the first count? How many spots? 3. Count again.
4, 5,
6. And then go one more.
7. So
7. This is how you write your answer in scientific notation. You write down the number 2.45. You can chop up all the zeros if there's a bunch of zeros, those are insignificant. You put a times 10, because that will move the decimal for you, it'll add zeros as well. And you're going to put a 7, because you moved, and the 7 is the power that's on the 10. Okay?
Huh.
That's what we call proper scientific notation. Now, if you move the decimal anywhere, so Sam, one of the things you kept saying, like just move it 4 or 5 spots.
Yeah.
Okay? If we moved it 4 or 5 spots, that'd be like, let's say 4, we moved it here. You could write down that number as this. 245 0 point whatever, and you put the decimal after it. Okay? So if you move your decimal 4 or 5 spots and you put the decimal here, okay?
Yeah.
This is what we have, then we put times 10. And then you put how many spots you moved it, well we moved it 4. These mean the same thing. One of them is the one that I want, the top one. The top one is called proper. You moved it all the way to the farthest spot on the left. This is proper scientific notation.
So did you get to go out at all? That's
No,
cool.
I'm gonna go out tonight.
Go
So,
on.
yeah.
Yeah. Same
It's supposed to
way.
warm up Wednesday, so I gotta go out tonight. So, alright. So, we need calculators though, because we're gonna talk about how to type this in on your calculator.
Because what happened?
Okay.
We have big birds around.
Yeah.
Oh, listen, we'll repeat that. No problem.
Okay, so I'm going to show you that this will give me the same answer on a calculator. So here's my calculators. Okay, turn it on.
Unclear.
Okay, clear it out, clear it out.
Yep.
Okay, so type in 2.45. So 2.45. So we're typing this. Now, here's what you're going to hit next. You're going to hit the little second key, and then you're going to hit the little X to the -1, so right above the number 7, that button. So put the little E on your screen, correct?
Mm-hmm.
Then type in 7, the power that you just put on it, and hit equals.
Oh, hey.
And it gives you the same number. Okay? It's going from scientific back to normal. And you can bounce back and forward. Okay?
That's cool.
So again, I'm going to put it on camera so that hopefully you can see this. So again, you type in the 2.45, you hit second, and you hit the little X to the -1 key, so it puts a little E on your screen. And then you're going to type in the 7 and hit equal. Boom. Okay. All right. Now, if we had a big number, let's say we had a really, really big number, and your calculator chose to just display this number in scientific notation. So something like this. So it chose to write this number down. Let's go to the 11. What does that number actually mean?
Divided by.
So, what does the 11 mean on that power of 10? What did the 7 mean? What do we do?
3.
What did the 7 mean?
Move the decimal
Exactly.
about that many
So,
times.
yeah, we're going to move this decimal. Since this is an 11, we can change this number back to the big number. We're going to move this decimal back 11 spots. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and this is where the decimal will land. And I can fill in all these gaps with zeros.
That's a big number.
Big number, right? In fact, if I write this down, I put all my commas in there.
It's even bigger.
So there, 1,
Did you
2,
think
3,
you were out in the road yet?
and then 803. All right, and what this number is, if you actually look at it, so let's see, 3, 3, 3, yeah, so I wrote down my number right. That is 803 billion. Again, how I know this is going to be a big number, if this number is positive, if that's a positive number there, your number is bigger than $1. and you had to figure out how many spots you move your decimal. So it's going backwards and forwards. Sometimes your calculator will actually choose to display that answer. And why I'm concerned about this, let's say you're doing math on your ITBS test, your math test, and you're typing stuff in your calculator and you hit enter, right? And it displays this on your screen. Times 10 to the 4th. And A, B, and C, D, and you know, it had your multiple choice, you know, but this is what it's showing you in your calculator screen, and these were your options.
So do they just run the ITBS test through like a mini thing by itself and run through
Oh, when they grade it? Yeah, I would assume they do. Yep.
and just slide it
Yep,
through?
slide it through and it grades instantly. Yep. Alright, if these are your answers for A, B, C, and D, this is where I know I'm gonna catch people. Because you're gonna look at your calculator and go, okay, it's 8.03, everyone go, oh, it's that answer, it's letter A. That's not the answer. Because what does that times 10 to the 4th mean? It meant, like what we did over there, where you moved your decimal. How many decimal spots am I moving mine? 4. So you move it back 4 spots. And since it's positive, I'm going back this direction because that's a big number, right? So I go back 4. Which one is it? Which letter?
D. I want to say D.
Nope.
Ah.
Move your decimal back 4 spots. I already said it's not D.
Oh,
Here's the reason why.
C.
Here's the reason why it's not letter D. There's no 0 between the 3 and the 8. Add a 0. So it's probably letter C. They moved it back 4 spots. 1, 2, 3, 4. So it's this one. So this is the one. So it's 80,300. Okay. Here's what I'd like you to do right now. I would like you to make up a 5-digit number on your paper, but only the first 2 numbers actually have numbers and there's a bunch of zeros on it. A 5-digit number, the first 2 numbers are actually digits, the rest of them are zeros. Make up one right now, 5-digit number.
5, so we have to have 5 actual numbers.
5 actual numbers, the first 2 are actual numbers, the rest of them are zeros. You have a 5-digit number.
Done.
Okay? Okay, we'll go through it here in a second. Okay, I want my 2 examples, so a 5-digit number.
Oh, different number, okay. 2,
Does it
4,
have to be like?
5.
5 digits, the first 2 numbers have to be
Does
numbers.
it like have to be big?
Does
or
the rest
small?
have to be?
Doesn't matter. So I want a 5-digit number, the first 2 numbers have to be big. Or just actual numbers. So, Eric, give me yours, what do you have?
All 5s.
All 5s? You have any zeros in there? Because I told
No.
you you had to have some zeros. The first 2 numbers had to be numbers, the rest of them had to be zeros. So, make up a new number. 5-digit number,
Doesn't matter how many zeros.
5-digit number, first 2 have to be numbers, the rest of them have to be zeros. So, Sam, give me yours.
Would 9.9 and then like 3 zeros work?
3 zeros, okay? That is a 5-digit number.
35.
Okay, 5-digit number with zeros on it, right? Now, I don't know if you have a decimal, I think you said decimal. Let's assume the decimal's in the back. So it's 99,000, right? I want this in proper scientific notation. So how many spots do I need to move that decimal? So it's behind the front number on the left. How many spots do I have to move that decimal? So it's way up here. Count.
5.
Nope. How many spots till it's behind the first number? Count.
4.
No, 4.
4. So we put a times 10 with a 4 on it. These in the same thing. Okay? Okay, Eric, give me your number now.
55.000.
Alright, 55.000. Okay, so you did a 5-digit number. We got a bunch of zeros. Now you have a decimal in yours, which I think Eric, you even said, or Sam, you even said you had a decimal in yours, but I didn't write mine. I didn't write it. Okay, so Eric, you had this, right? So you have to move the number behind the first number on the left. So you have to write 5.0 times 10, and how many spots do you move it? What? Say it. How many spots do you move it? So it's behind the first number on the left. How many spots do you move it? 1. You put a 1 on it. That's your answer. That's proper scientific notation. You've got to count how many spots you move your decimal. Okay? Alright, is there any questions with that?
No, we're with
Okay. Now, let's do small numbers now. So I'm going to restart my camera. We're going to do small numbers now. Okay, here we go.
Sure. That's a 1.
Alright, Next one here. Now we're going to be dealing with the rational numbers. Okay, so rationals. Okay, so rational numbers. Okay, so here's how this works. Rational numbers are anything you can write as a fraction. Anything you can write as a fraction. They could be decimals. If they are a decimal, because decimals you can write as fractions, we're going to learn that in the next couple days in here, possibly as early as Thursday and Friday. The decimals, what we learned, if they repeat, they're repeating decimals, or if they're terminating, that means ending decimals. So if they terminate, we can write it as a fraction. Okay? Alright, but that's kind of the idea, that's what a rational number is. So it's anything you write as a fraction. So I want to write a decimal here, and something very, very small. 0.000892. Okay, you agree that is less than $1?
Yeah.
Okay, it's really small. Okay, I want you to move the decimal bit so it's behind the first number on the left. So what's the first number on the left? The leftmost number?
2.
Leftmost number. That's the right. What's the leftmost number?
0.
Ow. Left. Ignoring zeros. What's your leftmost number?
Oh,
Left.
9 or 8.
8. So you're going to